Good morning, everybody, and welcome to our second part about prime and composite numbers. We are going to be talking about divisibility rules because when you're trying to figure out if a number is prime or composite, it's good to be able to know some rules that help you determine if a number is divisible by something else. So everyone should have this small little chart that they can glue in because I know in this video you can't really see these words. So I can give you kind of a zoomed in look at this real quick. But each student will have this glued in, and we're going to talk about each of these as we go so that you kind of get an idea of how this works. So at the very top of this, I want you to write divisibility rules. Now, most likely you're going to need to take 2 pages in your math notebook to do these notes side by side. That's perfectly fine. No worries about that. So we're going to take a look at a couple of different numbers in order to really be able to understand what this means. Now, when we talked about prime and composite numbers, we did a few examples, and we're going to kind of go through those same examples again. So we talked about the number 18. We talked about, let's see here, 31. We talked about 7, 97, 1, 2, 3, 4, 5, and the number 40. Now, under each of these, I want you to start by writing the numbers 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I probably should have given that a little more room, but that's okay. Y'all can learn from my mistakes. And all right, so now we have our potential factors lined up, and now we're going to figure out how these numbers are divisible. Maybe I'm going to come through and I'm going to break these apart a little bit just to give myself some space. So you may have this on one page of your notebook and these 4 on another page of your notebook, and that's perfectly fine, however you want to do this. So now let's start with the number 18. We know that no matter what, we can multiply 1 times 18 to get 18. The same way we can multiply 1 times 31, 1 times 7, 1 times 97, and 1 times 40. 1 times itself is always going to be a factor. But we have to determine if anything else can be multiplied together to get these numbers to determine whether they are prime or composite. So starting with 18. For the divisibility rules for the number 2, it says a number is divisible by 2 if it ends in 0, 2, 4, 6, or 8. This ends in 8, so we know that we can multiply it by 2, and if we know our multiplication facts, 2 times 9 equals 18. 3 says a number is divisible by 3 if the sum of its digits is divisible by 3. Well, I know that 1 plus 8 is 9, and 9 is divisible by 3. And so therefore 3 times 6 equals 18. A number is divisible by 4 if its last 2 digits are divisible by 4. Well, 1 plus 8 is 9. And therefore, or I'm sorry, I apologize, I was adding them up because it just says the last 2 digits. Well, the 2 digits are 18. 18 is not a factor of 4 because 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and 4 times 5 is 20. So we can automatically say that 4 is not a factor of 18. A number is divisible by 5 if it ends in 0 or 5. Nope. A number is divisible by 6 if it is divisible by both 2 and 3. Well, we've already figured out that it's divisible by 2 and 3, and 6 times 3 equals 18. Now it says there is no simple test for divisibility by 7. So if this is where you have to know your multiplication facts. 1 times 7 is 7. 2 times 7 is 14. 3 times 7 is 21. So therefore, nope. It says a number is divisible by 8 if the last 3 digits are divisible by 8. Now 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. So no, it is not. We already know that 9 is a factor because we can multiply 9 times 2 to get 18. And it says a number is divisible by 9 if the sum of its digits is divisible by 9. So 8 plus 1 is 9, so therefore it does fit that rule. Now, a number is divisible by 10 if it ends in 0. Well, this automatically doesn't fit because it doesn't end in 0. So now we have a list of all of its factors, at least 1 through 10. And because it has multiple factors, we know that this number is composite. So let's look at 31. By the rule of 2, 31 does not fit. By the rule of 3, it does not fit. Does not fit the rule of 4, 5, 6. 7 has no easy rules, but if I know that 7 times 4 is 28, 7 times 5 is 35, 7 doesn't fit. It does not fit the rule of 8. It does not fit the rule of 9, nor 10. So if the number's factors are only 1 and 31, then you know it's prime. Let's look at the number 7. Does not fit the rule of 2, does not fit the rule of 3, nor 4, nor 5, nor 6, nor 7. And since 7 can't be divided by 8, 9, or 10 evenly, we now know that 7 is a prime number. Let's look at 97. This one's going to be a little trickier. It does not end in 2, 4, 6, or 8, so it cannot be divided by 2, so therefore 2 is not a factor. 9 plus 7 is 16, and 16 is not divisible by 3, so that's not right. It's not divisible by 4. It doesn't end in 0 or 5. It's not divisible by 2 and by 3, so 6 won't work. Now 7, I can think about this. If I know that 7 times 11 is 77, 7 times 12 is 84, so that means 7 times 13 would be 91, and 7 times 14 would be 98. So that's not right. And the rule of 8, 8 times 10 is 80, 8 times 11 is 88, and 8 times 12 is 90. Oh my goodness, my brain just went kind of crazy there for a second. And that happens. You ever can't remember a factor? No worries. Work it out. So I'm going to take my little chart here because I know multiplication. I can do 12 times 8. 2 times 8 is 16. 1 times 8 is 8 plus 1 is 9. I thought it was 96, but my brain just wasn't cooperating. So 96 is not going to work. And which means if I'm adding in another 8 there, it's not going to fit. So 8 is obviously not a factor. Now, 9 times 10 is 90. 9 times 11 is 99. So nope. And 97 does not end in 0, so it's not divisible by 10. Therefore, we've proven once again that 97 is prime because the only factors are 1 in itself. Now, let's look at 40. Now, by the rules of 2 that ends in 2, 0, 2, 4, 6, or 8, it's divisible by 2. Well, I know that 2 times 20 equals 40. The rules of 3, if the sum of its digits is divisible by 3. Well, 4 plus nothing is 4, and 4 is not divisible by 3. A number is divisible by 4 if its 2 digits are divisible by 4. Well, we already know that 40 is divisible by 4 because 4 times 10, and we can even go down here, if we know that 4 times 10 equals 40, then we can say 10 times 4 equals 40. Make that easy on ourselves. If we know our multiplication facts, we know that 5 times 8, so we can fill in 8 times 5. Now a number is divisible by 6 if it is divisible by both 2 and 3. It was only divisible by 2, not by 3. So we can mark out 6 as a possible factor. We're going to have to use our multiplication facts to solve by 7. I know that 7 times 5 is 35. 7 times 6 is 42. So 7 cannot be multiplied by any number to equal 40. A number is divisible by 9 if the sum of its digits is divisible by 9. Well, 4 plus 0 is 4, and that cannot be divided by 9. So therefore, now we have our list. We have multiple factors other than 1 in itself, so that makes 40 composite. All right. So now you have a helpful chart to guide you through figuring out if numbers are composite or prime using divisibility rules. I hope that this helped, and if you have any questions or need any support, please let me know. I hope everybody has a great week, and we'll talk to you next time.